All right, so we did this last time, so I'm just going to kind of leave this one blank, and we're going to kind of cover it up if we would. So we're just going to be working on the right-hand side of our foldable, where we have a trinomial where x is greater, or a is greater than 1. Your leading coefficient's not 1, it's not -1, and in this case, we cannot take the GCF out, okay? This is a special case. We're going to deal with lots of special cases when we deal with factoring. But the first thing you always want to look for is a GCF, and there's nothing here. Because if there was a GCF, you would do it like we did on the left-hand side, and that's what we did before. We took that 2 out, and then we factored what was left. On the right-hand side here, there isn't a number we can take out, so we have to add an extra step into our factoring. We are still going to create our little organizational tool, and we're going to figure out the 2 numbers that go in there. However, and this is the important part, the number on the top is not -4. Okay? It's not. What it is 5 times -4. So it's -20. Okay? Because that's the way it works. Think back here. If we did some of these factorings, and we would go ahead and multiply to be 6 and add to be 5, what's the number in front of here? 1. So 1 times 6 is 6. So anytime you have a number in front, you just have to multiply it. So 5 times -4 is -20. What are they going to add to be? -8. Always your middle number. Okay? So let's think about some factors of -20. Since it's negative, if you remember from this morning when Tim told us, that means the 2 numbers, one would have to be positive and one would have to be negative. Travis, you're not even writing it down. Why are you sticking your tongue out at people across the... So stop. You need to focus at me. Okay, continue. Keep writing. Travis, continue. You guys know that you're recorded, right? And you know that it goes on School Fusion and YouTube, and I can talk to your parents and say, I want you to listen to this particular day because I had to call their name 4 times to be quiet. Right? Right, and it's still being recorded. Continue. No, add to be the middle number. The middle number, right here. The middle number. Oops. All right, so let's think about the factors. Okay? All right, let's see. Let's write some factors of -20. We have -20 and +1. We have 20 and -1. None of those work. But then, Shamar, what did you say it was, darling? 2 and -10. They multiply to be -20, and they do add to be -8. So he's right. 2 and -10. The 20 came from what I multiplied. 5 times -4. You multiply. You're just trying to, your 8x stays the same because you're rewriting that term. Okay? Then the only extra step that we had to do here was we had to multiply the first term times the last term. The only difference is this number here. Everything else is exactly the same. So I'm going to use the 2 and the -10, and I'm going to rewrite my terms. 5x squared plus 2x minus 10x minus 4. Everything else is exactly the same. Okay? Once I've gone ahead and rewritten, now remember what I did. The 5x squared stays the same. The -4 stays the same. All I'm doing is taking this number and rewriting it like this. Because 5 times -4. Yes, just in this case. Now I'm going to group. First and second, third and fourth. Just like I did before. At this point, what am I looking for? What's it called? Thing to take out, which is called the GCF. What's the GCF between 5x squared and 2x? Just an x. When I take out the x, that was wild. When I take out the x, okay, whoa, let's cut that out. Okay, take out the x. What is left? 5x plus 2. Now, I absolutely have to have this be the same in the second group. Has to be the same. So looking at the last two sets of numbers, what number can I take out so that I will be left with 5x plus 2? A negative 2. Because negative 2 times 5 is negative 10, and negative 2 times 2 is negative 4. Goes into both. It's called the GCF.
Negative 2 goes into 10 and 2.
Say that again?
Why is it you do negative 2?
Because I know these have to be the same, and I know that I want them to equal this. So 2 times 5 is 10, 2 times 2 is 4. So my two factors in this case are 5x plus 2, because that's the common factor, and then x minus 2 is the other one.
So for this one, you can't do it with the numbers?
No, it doesn't work. That's why I never teach you that. Okay? Shh. The reason that I taught you the other way to factor and was kind of like the long way, the rewriting of the middle term, is because this is how you have to factor when you have a number in the front. Okay? So it's the same process. So let's leave this one in your foldable, and I want you to, on a scratch sheet of paper somewhere, I have two more for us to practice. These are the harder kinds of factoring. There are others that we will eventually get to, but for now, this is about as hard as it's going to get. Okay? So let's try two more. Okay? We're just going to do two different problems. You don't have to put these in your foldable. Just try them in your notes. Okay? We're going to do one at a time. What is always the first thing you want to look for? The GCF. Looking at the first example here, is there a GCF that I can take out of all three pieces? Well, 3 doesn't go into 11. If it was a 12, I would agree with you. But there is not one number or letter that goes into all three. How about over here? 3x squared, 11x, and 20. Is there any number or letter that can go into all three? So I can't take out the GCF. So I always check for that first. Because the number with the x squared, that a, is bigger than 1, that's my clue that I have to be careful when I'm factoring. So we'll just do one at a time. On the left-hand side, what number do they have to multiply to be? 18. Where did the 18 come from? 6 times 3. Okay, they have to, so the numbers I'm going to use multiply to be 18. Matthew, what do they add to be? 11. Very good, because it's a number with the x. Very good. So now we have to kind of think of factors, some numbers that would satisfy this.
So that first one, they always times the n?
First times the last. And you can always do that, because sometimes if it's a 1, 1 times 3 is 3.
So now I have two ways to do it.
There you go. What numbers multiply to be 18 and add to be 11? And some of you already have it, because some of you are quick with that. I'm not as fast. I'd write it down. 18 and 1. They both positive or both negative, or they're both positive in this case. It is 9 and 2. Very good, because those add to be 11. So 9 and 2 go here. So I need to rewrite my middle term. So I have 6x squared plus what? 9x plus 2x plus, there you go. All right? So all I've done is rewrite it. Now I'm going to group. Looking at the first two and the last two. So I'm going to pause for a second. I want you guys to catch up and start thinking about what I'm going to do next. So the GCF, Raul, with the first two is what? What's the largest thing, letters and numbers, that comes out of both? There's one number. 3 is definitely a number that comes out. Just 3x.
Why? Where does the x come from?
They both have an x.
Oh, I think someone that would do it.
I'm looking over here. Just the first two.
Thank you.
Okay? Joseph, when I take a 3x, what's left? 2x plus 3. And I know that I have to 100% have to have a 2x plus 3 over here. Yes, ma'am. Shh. Because 3x is the GCF out of the first two terms. Because 3 times 3 is 9. That's why the parentheses are there. It's like reverse distribution.
2x is already over.
Okay, you guys, one person's asking a question. Go ahead, Alexis. 3 times 2 is 6. The 3 goes outside the parentheses. The parentheses mean that I'm taking it out of both. 3 times 2 is 6. 3 times 3 is 9. It's like I undid the distribution.
Oh.
I'm reverse distributing. He has a question first, and then I'll ask you.
So if there's more than 2 GCFs.
Shh. You take out everything you possibly can. That's why the 3 and the x came out. All right, Tim. Go ahead.
That 2x, bro, just came down. That 2x plus 3.
I haven't even done the second half yet. I'm still worried about over here.
So
I'm
all
not-
that was-
I'm-
all that was from the first.
Yes, I am not done yet. Let me finish. This is not hard. It's not easy stuff. I know that these two things absolutely must be the same. 2x plus 3 and 2x plus 3. That's why I wrote it there. And exactly right. I know that looking at my last two terms that I'm grouping, I would take out a 1. So here is where, once I have this, I'm going to write my two factors. The two factors are 2x plus 3 and 3x plus 1. Gabby, where'd I lose you? Because 2x plus 3 is already there, and I know that 1 times anything is itself. If I rewrote what's in blue because I didn't even look up at the top. I knew that had to be a 2x plus 3 because of this one on the left-hand side.
So why do you think
So let me answer one at a time. I took the 2x plus 3, I looked up here. Since it's exactly the same, I just put a 1 there, because 1 times itself is the same. Like in the other example, it wasn't the same. These two, that's not the same. So I knew I had to put a 2, because 2 times 5 is 10. Okay? So you have to write these two things no matter what. Then you look up top. Okay? All right, what else we got? Oops.
I was first.
All right, I'm listening.
So where's the 3x? Where'd that 3x come? Where'd the 1 come from?
Okay, that's what Gabby was just asking. What I've written in blue, I wrote in blue because they have to be the same. Then I looked up here and what's in yellow, the last two terms. Since they are the same, I know I multiply by a 1 because 1 times anything is itself.
But I understand that 1 on the right, but I don't understand where you got the 1 on the left. Did you go back outside?
I don't see a 1 on the left.
No,
Oh, you mean this one here?
Yeah. No, I don't understand. No, I understand when you got like the equation on the left side. I understand where you got it on the right side, but not the left. I don't understand why you got the 3x plus 1.
What's in yellow?
Yeah.
Okay. So let's go from the second to last step to the last step. It's kind of like a GCF. They both have in common the 2x plus 3. What's left over? 3x plus 1. That's why I drew those little arrows.
Oh, so they go to one side.
They go to one, and then they go to the other.
You could have just said that you should do an arrow.
I think I did say that. All right. All right. Can we try the one over here? All right. I want you to try this one. I'm going to pause the recording. I want you to try this one on your own. This one. The two numbers that they multiply to be is going to be negative 60. They're going to add to be 11. Travis, what two numbers did you get? Very good. 15 and negative 4. So I'm going to rewrite this using 15 and negative 4. So I'm going to say 3x squared plus 15x minus 4x minus 20. Then I'm going to group. Okay? What is the largest number that can be taken out of both? Kimberly, what did you get? Out of the first two. 3x, very good. When I take the 3 and the x out, what I'm left with is x plus 5. Right, Raul? See where, because I took it out of x, I got an x left. But then you had some issues on the rights too, so we gotta be careful. What do I know has to be the factor over here? No? X plus 5. And the number that goes in the front, not just negative 4. So my two factor, you had a 4x though. 3x minus 4 and x plus 5 are the factors. Okay? Yes. You sure would. You would get this. It doesn't matter. This is a really good question. What if I wrote these in the opposite order? What if I said negative 4x and 15x? It doesn't matter. You should still get the same answer.
How would you get x plus 5 out of the x?
You want me to do it the other way? I'll show you. All right. Let me prove to you that it wouldn't matter. So 3x squared minus 4x plus 15x minus 20. What if I wrote them, the two middle ones, in the wrong order, the opposite, not the wrong order, but the opposite order? Shouldn't matter. If I look at my first two, what can I take out? Only an x, and I'm left with 3x minus 4. This has to be a 3x minus 4 over here. What can I take out of my next two to get that? A 5. So the two factors are x plus 5, 3x minus 4. Doesn't matter the order that you do it. Okay?
I just don't understand how you distributed it from the blue down there.
I didn't distribute anything.
But how'd you get that problem there?
How'd I get this to here?
From the blue, yeah, like,
Because I looked at the first two and I grouped.
first thing you're supposed to look at when you want to move after that step.
You look at the first two things and you look at the largest number that goes into both. It's called the GCF. 3 goes into both and so does x. I pulled it out.
So you put out 3, because 3 goes into 15,
And 3 goes into 3.
and 3 goes into
Mm-hmm.
and then what do you x plus 5?
Because if I take a 3x out, I look at what's left. I took a 3x out of here, I'm left with just a plain old x. I took a 3x out of here, I'm left with a 5. Because if I distributed these two things, I'd end up with what I started with. Okay? Okay. Sorry. All right. Shh. And again, what I did underneath here in the red is just to prove to Louise it doesn't really matter how you rewrite the two middle terms. All right. So what I have for you to work on for the rest of class, you have 50 minutes, plenty of time. It is due today, okay? You're going to turn this into me today. So here's what you're going to do. Shh. You sure should have already worked on 1 through 9, right? That should be done. We have that finished already. I assigned 10 through 18 the first half of class today, this morning. I realize you probably didn't finish that, so you can continue to work on that. But now you should also be able to do 23 through 20, we'll do 23 through 30, okay? And then this, and by the way, the ones on the back, they're all kind of mixed together. You can look for a GCF, sometimes you have to do a trinomial, etc. But these are all the problems that you need to get done, okay?